Hi, and welcome to my video on extra constructions number 2. And this video is going to be on finding the center of the perpendicular bisectors, medians, altitudes, and angle bisectors. So let's start with the first one. Find the intersection, point of intersection of the perpendicular bisectors of each side. So let's take C, vertex, and take a radius more than half the length of BC. So let's take this one right here and draw an arc. So we place it at B and draw an arc. They'll intersect. And at the same time, I'll use this one up right here. And we can also use the same arc. I'll do a different arc. No, I'll use the same arc because the triangle is, so we'll use, let's make it, trying to make it so it's the same. It's a convenient arc, but I probably should have taken different radius. And we'll put it at A and using the same arc. There it is, they're all intersecting. And I didn't do the one from C far enough, but I construct the perpendicular bisectors by let's join these up, and I'll have the perpendicular bisectors. So the perpendicular bisector BC is this from here to here. That's the perpendicular bisector, and I'll extend it out because they're going to meet. Perpendicular bisector of AC is through here. There it is. And the perpendicular bisector of AB is from here to here. And they'll all meet at one point. And that point is right there. So let's call that point O. So the perpendicular bisectors meet at point O. And what happens is that if you take a compass and go from the center O where they meet, and you go to point A, then that's the distance. What's A? So OA, take this radius. OB is the same radius, and OC is the same radius. So we can draw a circle that'll go through A, B, and C. So this, where the perpendicular bisectors meet, you have this center, and this center is the same distance from A, B, and C. So we call this center, and I have all the arcs here, we call this center circumscribed. Like a circumscribed, but a circumcenter. It's the circumcenter. And the circumcenter means the circle is circling around the triangle. So the triangle is inside the circle, or the circle is outside of the triangles with the vertices of the triangle on this circle. So this is the circumcenter. Okay, let's see if we can find another center. Find a point of intersection of the medians. So the medians median goes from A to the midpoint of the opposite side, BC. The median from C goes to the midpoint of AB. And the median from B goes to the midpoint of AC. So we can do all the perpendicular bisectors again like I did just then. But it's just as quick if you want to use your ruler. You can get the midpoint, that's 100. So 50 is the midpoint of here. So this is the median. So if I did the perpendicular bisector, then the perpendicular bisector, and I'll just do one to show you, the perpendicular bisector, the line between B and C, I have to take a radius more than half the length. So let's take this one. And from B, I'll take this one. So what we have is that the perpendicular bisector is right here. So this is the perpendicular bisector from here. This segment is perpendicular to BC, and this is the midpoint. Therefore, when I draw A to, let's say this is M, so this is the perpendicular bisector. So if I call that FG, FG is the perpendicular bisector of AB, making a right angle. M is the midpoint. So if I join up A to M, I have, this is the median, because the median leaves the vertex and goes to the midpoint. So if I did that for the three of these, like I did in the video, in the other page 2 of the video, so get the midpoint of this as 80, 85, so it's about right here. The midpoint is right in the middle. So that's the midpoint. So C going to this point. Let's join that up. There's C going to that point. And this is the median because it goes to the midpoint. And again, we're going to be approximate. So that's the median. So this is the midpoint because we found it. I could do the perpendicular bisector like this from A and B, but this is the median. And the medians are meeting right here. Now, again, without doing the perpendicular bisector like I did first, that's roughly 90. So we take about a 45, which is the midpoint right there. So if that's the midpoint, a segment drawn from the midpoint to B, this segment is, so this is a midpoint. So let's call this F or H. I got F there. So that means that AH is equal to CH, and that means this is a midpoint, so BH is a median, and the median is meeting, as you can see, we got this one is meeting here, so they're all meeting, not right there, they're all meeting right here. So this median, and this one, they're all meeting at this point. And where these medians meet is called a centroid, C-E-N-T-R-O-I-D. Central, I think of center in the middle, so this is in the middle, centroid. I remember studying this when I was in grade 8 or 9, so I memorized the names and where they came from. The medians meet at a point, and that point is called a centroid. Perpendicular bisectors meet at a point called a circumcenter. And let's continue. Find the point of intersection of the angle bisectors. So let's do the angle bisectors and see where they meet. So an angle bisector, you take B and you cut the sides of the angle. So let's label this A, B, C. Let's go with a D and an E. So I place my compass at D and E, more than half the length. So this is more than half the length of DE. And we place the compass at E with the same radius. They intersect. Let's say they intersect at F. So I'll draw BF. And BF is the angle bisector. So F to B, there it is. So that's the angle bisector. So that means this angle is equal to this one. Now I'm going to get the angle bisector of angle A. So we open up our compass to whatever radius. So we just open. I could make it, in here, but have it out here a little bit. Draw an arc to cut AB and AC. So A, these 2 points are the same distance from A. So let's call this X, Y. So take our compass, place it at X, and place it at Y, and this is the segment from X to Y, so I have to take the radius of the compass more than half the length of XY. So that's more than half the length. And just make it a little bit longer so arcs won't get mixed up. So there's one there, and we place it at X, and we draw another one, so they intersect. So what I have they're intersecting at O. So I'll draw OA, and OA is an angle bisector. So OA is an angle bisector. Notice they're meeting here. Now I'll bisect angle C. So I'll take a radius on my compass, and I could bring it in smaller so the arcs won't go so far. So cut AC and BC. There it is. Take my compass, and I'm going to name those 2 points as M and N. So the compass, radius of the compass has to be more than half of MN, and that's more than half. So at M, draw an arc. At N, draw an arc with the same radius, and join them up. And when I do, I have another angle bisector from C to this point. Let's call this point G. There we go. Notice all 3 are meeting right here. So let's call this point W. So, because these are angle bisectors, so this is the center of the angle bisectors. So when I take the center and I go to C, notice it won't go through A and it won't go through B. So it's not like the perpendicular bisectors. So what's about this one? Well, we take a distance from W to AC. Let's go from W and just touch AC. Here's W, and we're just touching AC. So let's draw a circle here. So it's just touching AC. And notice, off a little bit, because the point is off. I'm making my rotation here. 3, they should, if I do it right, get a little bit better, a little bit better. Again, you got to be. So this circle, if it's done perfect, this center will be the center of the circle that's touching here when I go around, and touching here, and touching here. So we did it right perfectly. Then this circle, the center, this is a circle that touches at one point here, and at one point here, and at one point here. So that means that this is what we call the in-center. The in-center. It's called the in-center. So this center is inside the triangle, and this circle is inside of the triangle. Remember, the perpendicular bisectors, the center was such that the circle was going through the vertices out here. So the circumscribed, round, circumscribed center for perpendicular. So this is the in-center for the angle bisectors. It's called the in-center. And because it's touching at one point, that means that this line touching the circle at one point, this line CB is tangent to this circle with center W. AC is tangent to this circle right here, touching at one point. And AD is tangent to this circle, touching at one point right here. So the angle bisectors, the center where they meet is called the in-center. And that circle that's drawn will be tangent to each of the sides. And we have one more to do. What about using a ruler and compass only and find the point of intersection of the altitudes? The altitudes. Let's do some altitudes. So the altitudes, let's see what happens. I have to draw an altitude from A to BC. An altitude goes from C to BA. An altitude goes from B to CA. So let's start with C. I want to draw an altitude. An altitude is a segment. So a segment leaves C and goes perpendicular to this side. An altitude from B leaves here and goes perpendicular to AC, the opposite side. A perpendicular from A leaves A and goes perpendicular to BC. So let's construct an altitude from C. And it has the cut. So we're constructing. So it's cutting here. So I'm going to label A, B, C. I'm going to label that as D and label that as E. So place the compass at E. I'm going to take the distance of the compass more than half of DE. So more than half. So that's more than half. I'm going to draw an arc. Put it at D, and I'm going to draw an arc. And it will intersect the previous arc. There they are. They are intersecting. So now I take C to where the arcs intersect. There they are. So what I did, I constructed a perpendicular to BA from C. So that's perpendicular. So let's call this side M. So CM is perpendicular to AB. So this is an altitude. An altitude leaves the vertex and goes perpendicular to the opposite side. Now I'm going to construct an altitude from A to BC. So we stretch it out. Remember, it has to cut BC at 2 points. So that's pretty good there. And there. So notice the line is not extended. So what I have to do is extend BC out to find where that other point is. There it is. So let's say this is F and this is H. So I extended BC out so I could cut the arc. Now I take my compass. I have to get the radius of the compass more than half of HF. So more than half of HF. So let's see, there's H going towards F, more than half. So that's more than half. So draw an arc right there. Put it at F and draw another arc cutting the previous one. There it is. So when I join that up and I went from A, so this segment is, there it is. That's an altitude. So to leave A and go perpendicular to BC, there's the perpendicular to BC. So A and let's go S. Let's call that S. So that means AS is an altitude. It leaves A and goes perpendicular to the opposite side. And notice the altitudes are meeting here. And now let's draw an altitude from B. And again, I have to extend the compass out. So it has to cut the opposite side twice. So let's do this one. Okay, and again, what happens, I have it cut here, but it has to, I have to extend the side out. So when I do, I'm going to extend this side out because I need another point on the other side of C. So there it is. It's cutting right here. So let's label that as P and Q. So I place my compass at P and Q, but the radius got to be greater than half the length of PQ. Remember, if you don't take it greater than half, if it's less than half, the arcs won't meet. And let me show you that. I'm going to take a radius less than half. So there it is. So this is a radius less than half. So if I draw this arc here, and I put it at P and draw the arc, they won't meet. Notice? They won't meet. So I have to take a radius greater than half of PQ, the length of PQ. So there's, let's see, that's greater than half. So make an arc here and put it at P and put the same radius and make another arc intersecting the previous one. Notice I didn't draw it down far enough. So I got to go back, put it at Q, and draw. Now I got a meeting right here. So let's call this, well, we call it W. So we'll join W to B, make that segment. Here we go. So this is a perpendicular. So B, and we can call this WZ. Let's call this Z. So this means that BZ is perpendicular right here. So BZ is an altitude because it leaves a vertex and goes perpendicular to the opposite side. So this is the side of the triangle CA, perpendicular. Notice they all meet, all the altitudes meet right here. And again, it's the perpendicular bisectors that becomes the circumcenter, which circle is passing through all the vertices. The angle bisectors meets at the incenter, and the circle is on the inside, tangent to the sides. And this one is called the ortho center. It's the center of the altitudes, which is right here. Ortho. Ortho means right or straight up. So when we think of it, it's straight up. Right angle is ortho is could be mean right. I just look at the dictionary, and you see straight. So there's a right angle, right, straight. So again, the altitudes meet at the ortho center. And that's 4 different centers of the different, the angle bisector, the median, the perpendicular bisector, and the altitudes. And again, if you like my video, click the like button, click the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Notice, all one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.